why you can do that. But I wondered vaguely if it had something to do with compactifications. And that's what I'm going to say. Right, okay, and now like on this kind of structure, this sort of tropical curve metrized by some monoid, we can talk about piecewise linear functions, right, in exactly the same way. So definition of PL function on such an x is, as before, a pair of functions, alpha and mu, except now we just see them living on the whole of G and taking values in M, the groupification of M cross Z, and again it's going to be like the value on vertices and the slope. So there's going to be a bunch of conditions. So firstly, by convention, well, not by convention, you needed to make it work, the slope at any vertex is 0. Okay. The second convention, again, needed to make this work, is that the value at any flag is defined is considered to be equal to the value at the start point of the flag. And then the third thing is kind of the thing that makes it work is that again the value on the opposite flag, which by this convention is the value at the end point of the flag x, is equal to the value at the starting point plus the length times the slope. So in particular, this does now imply that mu of iota of x equals minus mu of x. Sorry, these are all i's, not iotas, sorry. Okay, so somehow the point is that we're still insisting that the slopes of our piecewise linear functions are integers, but somehow like the values that it can take at any of the vertices are now allowed to be in the groupification of the monoid. So before, like when our monoid was r greater than or equal to 0, like the groupification was just r. So it's kind of like piecewise linear functions with values in M group that have integer slopes, is what this definition gives you. And we can talk about, again, like, sorry.
How can you make sense out of the last 3 by adding integers to elements of M group?
Right, so L of x is an element of M group, so in particular it's a Z module, so I can multiply it by an integer. So yeah, so M group is a Z module, yeah. Right, and again, if I call this lambda, then lambda is linear. If and only if the sum going out of all edges going out of some vertex E, of some vertex V, sorry, all flags leaving some vertex V, if their sum over all the slopes is 0. So that's by definition. And again, the notation used in the paper is P of x and L of x for piecewise linear, stroke linear functions on x. And so just a kind of cute little result that I want to write down, which is kind of quite a nice analogue of a well-known result for algebraic curves, is that so if we say x is compact, if this function taking a flag to its start point is defined everywhere. So in other words, there are no infinite vertices. I really just, every flag has a start point and an end point. And then the lemma is that if x is compact, then the only linear functions on x is exactly the constant functions from x from G to M group.
Locally constant?
Locally constant. Thank you. So somehow at least I think the way you're supposed to think about this is like saying that on a projective curve the only regular functions are the constant functions. Cool. Right. So oh god. Right. No, I don't have much more I want to say. I want to talk about the two basic operations that we can do on these tropical curves. So the first is exactly the same as before. So, if I have an edge and I kind of write its length as the sum of two other things in my monoid, then I can just stick in another vertex and declare the two new edges to have those lengths. Works exactly the same as before. But there's now a new operation that appears, because I'm allowing an arbitrary monoid M to measure the lengths. And this is what's called edge contraction. So if I have, say, some x metrized by M, say, and I have a homomorphism of monoids, let's call this alpha, then somehow what I want to do is I want to say, well, all my edges have lengths measured in M, so I should be able to also consider them as lengths measured in N using this homomorphism. But of course, just doing that straightforwardly doesn't quite work because of our requirement that it's only proper edges that have non-zero length. So somehow to get this to work, we need to contract all the edges in X that have length in the kernel of this map. So to make this work, we need an assumption, which is that, let me get this assumption right. So which is that R defined on all flags X such that the length of this flag goes to 0 under this homomorphism of monoids. And now what we can do is we can define a new... Sorry, alpha, yeah. Thank you. Alpha is also a bad name because I've used alpha over there. Oh well. Sorry, guys. So we're going to define a new tropical curve y metrized by n by setting its set of edges and vertices to be the quotient of that of x by some equivalence relation where we say that x is equivalent to r of x if and only if alpha of the length of x equals 0. So in other words, if a flag has length that goes to 0 under this homomorphism, we're identifying it with its starting point, is what this is saying. So kind of the picture is if I started off with something like this, let's say L1 and L2, and then U, V, W, and let's say f of L2 is 0, then
Alpha.
Sorry, yeah, alpha alpha of L2 is 0, then the thing that I get is just going to have one edge of length f of L1. Sorry, alpha of L1. So I've contracted this edge to to nothing. Okay, so these are these abstract tropical curves. They're these like metrized by these monoids, piecewise linear and linear functions on them, and then we have the two basic operations of subdivision and edge contraction. And so the motivating example of where these are going to come from is going to be nodal curves. Because if we have a nodal curve, then we can form a graph, which is just the dual intersection graph. So the vertices are going to be irreducible components, the edges are going to be given by intersection points for these components. So this is kind of like almost one of these objects, except there's no monoid in sight at this point. But what we're going to see is that the monoids metrizing these dual intersection graphs are going to come from the log structures on our curves. So if we have like a log smooth curve, so like if we give our nodal curve some good log structure, then this is going to equip its dual intersection graph with the structure of one of these objects. And I'll leave you to have a think about what these two operations correspond to on the geometric side. Okay, thanks a lot.
Any more questions, comments? Everyone is?
Again, so here you say X is compact if R is defined everywhere.
Yeah.
But like in the classical pictures you drew in the beginning,
Yeah.
those were curves in GM, so they were not compact.
Yeah. So these won't. So somehow the point is when you go from those kind of pictures to these kind of abstract tropical curves, we're kind of throwing away the vertices at infinity. So all of these edges, or like these flags that originally started a vertex at infinity, don't have a starting point now.
Yeah.
That's somehow what's going on here.
Yeah, but R is defined everywhere means that there's no such.
Yeah. Yeah. Exactly. Yeah. Yeah.
You don't want any finiteness conditions to be compact as well?
They don't give them in the paper, I don't think. But yeah, that's a good point. It, like,
It's a bit weird.
Yeah.
yeah, they just insist that G is finite.
They
It
just say
seems reasonable,
G
right?
is a set. In the definition, say G is a set. They don't
Yeah,
know.
but then
But
I don't
then when
believe
they
this
define
implication
compact.
on... Oh, maybe,
Well,
yeah.
I don't remember seeing it in the definition, but maybe it is. It would seem a reasonable condition, right? Somehow. Can you enlighten us, David?
no, I'm just skimming through the paper, but no.
Okay.
No, they just say no. They don't require finiteness, but we could always ask them if they would like to.
Yeah.
But if they won't for the applications, they will be finite.
Yeah. And somehow, like they're all in applications, they're always going to be compact as well, because these dual intersection graphs, like we're really going to construct them to be compact.
If there are no more questions, then thank you. We should thank us again, and also remember that if you would like to join us for dinner, or if you'd like to volunteer, then hang around at the end.
Is er really famous? Nee. Ja, maar zoals ik ook begrepen heb, is dat een verslaagje irrelevant geworden. Dus alleen maar gebruikt weinige dingen.
Dus je mag dat in de definitie wel zeggen.
Ja.
Om de lezer te verwarren.
Ja. Het is waarschijnlijk heel hard nagedacht dat de eerste 3 levels ook waar zijn, zonder die voorwaarden. En dan verder niks over geschreven. Daar wordt de lezer altijd blij van.
Ja.
I take it you're going back to...
No, I'm gonna
Oh, okay.
come from the yeah, this I have to catch a train at 8 minutes.
Okay, yeah.
Wonderful.
Yeah,
Thanks.
Careful about ages with that stuff. Okay. but-
Yeah, sorry, I realised that some of the definitions possibly weren't quite like exactly right.
it's never right enough.
I might be interested in giving it.
Ah, excellent. That's exactly what we wanted.
Yeah.
Should I press some button?
Depending on
Ja, liefst